Examples of STARTSLP, CRATERSLP. They are commands for TAWERS mag welding. Use STARTSLP command to change the welding conditions from the initial condition to standard conditions gradually in the specified section after the arc start. Use CRATERSLP command to change the welding conditions to the terminal condition gradually starting from the specified section before the weld endpoint. 18.4.1 How to edit welding fine adjustment parameters. 1. On the command edit dialog box for STARTSLP, CRATERSLP, select a welding fine adjustment parameter table number, 1 to 10, for the parameters for the slope section. Click Detail button, then the specified welding fine adjustment parameters table is displayed to edit. 2. It is also possible to display the welding fine adjustment parameters table without editing the command. On the system screen, click Slope PRM, then the list of slope parameters table numbers is displayed on the right pane of the screen. Then, select the intended table number, i.e. SLP_PRM01, to display the table. Or from the menu, click View and File List, and then select the intended table number, i.e. SLP_PRM01, to display the table. Use this procedure if Slope PRM folder is not displayed even though STARTSLP, CRATERSLP commands are registered. Supplementary notes greater than 1, where to register the commands, STARTSLP, register the command to the arc start point where the command will be executed before turning on the torch switch. There is no precedence relation with arc set command. CRATERSLP, there is no specific rules for registration position. However, it is recommended to register to the arc endpoint so that it is easy to see where the slop starts. It is possible to use the STARTSLP command by registering to the arc start program to be called by arc_on. If STARTSLP command is registered to the arc start program, the command will be executed at restart operation of a weld section. It is not possible to use the commands by registering to the arc end program to be called by arc_off. Welding fine adjustment parameter table. System screen. STARTSLP, CRATERSLP command edit dialog box greater than appendix. 320 OM10090882E17. 2. Processing when the slope section setting is wrong. When either STARTSLP or CRATERSLP command is registered to a section of consecutive torque points and if the specified distance of the slope section is longer than the distance between torque points, next or back processing is applied. When both STARTSLP and CRATERSLP commands are registered to a weld section of consecutive torque points, a weld section, with no intermediate point, if preset arguments create inconsistency, such inconsistency will be corrected as follows. 3. Errors for Saint ARTSLP, CRATERSLP. STARTSLP CRATERSLP processing next D or T next of STARTSLP. D or T back of CRATERSLP. NEDT back of CRATERSLP sum of STARTSLP time TS and CRATERSLP time TC is bigger than the time required to travel between the torque points at the average speed for slope. TS and TC are applied by reducing the overall speed. The total travel time between the torque points is TS plus TC, asterisk if the same inconsistencies occurs using D, distance. The above mentioned method is used to adjust the inconsistencies. Error message cause E1250 weld slope command error 00 a negative value is assigned to the variable that designates the distance. For the slope section, E1250 weld slope command error 01, STARTSLP, and CRATERSLP commands was executed in a program without mechanism. E1250 weld slope command error 02, STARTSLP, and CRATERSLP commands was executed in an arc end program. E1250 weld slope command error 03. The parameters file for the slope section specified by STARTSLP, CRATERSLP command is deleted. Appendix OM10090882E17321 18.5 Sample programs of palletizing. 18.5.1 Sample 1. Operation. Pick up unloaded works and put in a pallet one by one in good order. Precondition. This sample program is a program to put the workpiece in a pallet one by one in good order using minimum teaching points. Therefore, the sample program abbreviated a program to pick up unloaded a work with pick up, and a program to release the work with work rel. In this sample program, teaching points are used to specify the row pitch and column pitch. P1 P2, placing the work. P3, specifying the row pitch. P4, specifying the column pitch. Note for better understanding, this sample program simply multiplied the taught row pitch and column pitch to specify the position. That means, the pitch errors at teaching are also multiplied. Therefore, the sample program is not suitable for a system that requires precision. To ensure precision, teach the endpoints of both row and column and then divide each point value by the number of column, row, n, minus 1. With this way, the pitch errors may be reduced. Relationship between work and teaching points. P1, P2, P3, P4, column pitch, row pitch, row, column, work, row pitch, n, pieces appendix. 322 OM10090882E17. Sample Program 1, Pallet 01. Program Description. Tool 1, TOOL001 Specify a tool jump to start MOVELP 15.00 meters per minute Specify the shunting point before insertion. MOVELP 25.00 meters per minute Specify the inserting point. MOVELP 35.00 meters per minute Specify the row pitch, P2 P3 distance. MOVELP 45.00 meters per minute Specify the column pitch, P2 P4 distance. Start operation starting point set GI001 equals 5 Specify the number of rows. Set GI002 equals 4 Specify the number of column. Set LI001 equals 0 Reset the row counter. Set LI002 equals 0 Reset the column counter. CNVSETGD0002P2 Get coordinates only. CNVSETGD0003P3 Get coordinates only. CNVSETGD0004P4 Get coordinates only. Sub GD0003GD0002 Calculate row pitch. Sub GD0004 GD0002 Calculate column pitch. LOOP2 for row loop. LOOP1 for column loop. C. Call pick _up pick up a work. Set GD0001 GD0003 Assign the row pitch value to the shift variable. CNVSETLR001 LI001 Convert the row counter into a real number. Mul GD0001 LR001 Multiply the row pitch by the row counter value minus 1. Set GD0005 GD0004 Assign the column pitch to the shift variable. CNVSETLR001 LI002 Convert the column counter into a real number. Mul GD0005 LR001 Multiply the column pitch by the column counter value minus 1. Add GD0001 GD0005 row shift value plus column shift value. Shift on robot equals GD0001 shift on the robot coordinate system. MOVELP 115.00 meters per minute move to the shunting point before insertion. MOVELP 20.50 meters per minute move to the inserting point. C. Call work _rel release the work. MOVELP 15.00 meters per minute move to the shunting point. Shift off end shift. Inc LI001 add to the row counter. If LI001 less than GI001 then jump LOOP1 else NOP if the row counter is less than the preset number of rows. Then jump to loop 1. Set LI001 equals O reset the row counter. Inc LI002 add to the column counter. If LI002 less than GI002 then jump LOOP2 else NOP if the column counter is less than the preset number of col. Jump to loop 2. GOHOMEMOVEPGPHOME 15 meters per minute move to the shunting point. Stop end of operation. Appendix. OM10090882E17323. 18.5.2 Sample 2 in this sample program, teach a user coordinate system taking the direction row as X, and the direction of column as Y. Specify the row pitch and column pitch with numerical values. P1 P2. Placing the work. Relationship between work and teaching points. P1 column pitch. Row pitch. Row. Column. Z. Y. X. Work. P2. User coordinate system. Sample program 1, pallet 01. Program description. Tool 1. TOOL001 specify a tool jump to start MOVELP 15.00 meters per minute specify the shunting point, before insertion, MOVELP 5.00 meters per minute specify the inserting point, start operation starting point set GI001 equals 5 specify the number of rows. Set GI002 equals 4 specify the number of column. Set LI001 equals O reset the row counter. Set LI002 equals O reset the column counter. STTEL grand. X #GD0003 equals 100 X element of row pitch STTEL grand. Y #GD0003 equals OY element of row pitch STTEL grand. Z #GD0003 equals OZ element of row pitch STTEL grand. X #GD0004 equals OX element of column pitch STTEL grand. Y #GD0004 equals ATY element of column pitch STTEL grand. Z #GD0004 equals OZ element of column pitch, LOOP2 for row loop, LOOP1 for column loop, C, call pick _up pick up a work. Set GD0001 GD0003 assign the row pitch value to the shift variable. CNVSETLR001 LI001 convert the row counter into a real number. Mul GD0001 LR001 multiply the row pitch by the row counter value -1. Set GD0005 GD0004 assign the column pitch to the shift variable. CNVSETLR001 LI002 convert the column counter into a real number. Mul GD0005 LR001 multiply the column pitch by the column counter value -1. Add GD0001 GD0005 row shift value plus column shift value. Shift on user number 1 equals GD0001 shift on the user coordinate system. MOVELP 115.00 meters per minute move to the shunting point before insertion. MOVELP 0.50 meters per minute move to the inserting point. C. Call work _rel release the work. MOVELP 15.00 meters per minute move to the shunting point. Shift off end shifting LI001 add to the row counter. If LI001 less than GI001 then jump LOOP1 else NOP if the row counter is less than the preset number of rows. Then jump to loop 1. Set LI001 equals O reset the row counter. Inc LI002 add to the column counter. If Li002 less than Gi002, then jump LOOP to else NOP if the column counter is less than the preset number of jump to loop 2. GOHOMEMOVEPGPHOME 15 meters per minute, move to the shunting point. Stop end of operation. Appendix 324 OM10090882E17. 18.6a Program to calculate distance between points. A program to calculate distance between points by calculating differences of x, y and z of 2 points respectively, and then find the distance from the square root of sum of the squares of x, y and z. Equation 18.6.1 Program, PtoPlen. The following is a program to calculate distance between points, point 1 and point 2, and then add the result to GR0001. The coordinate of the point 1 is assigned to GD0001, and that of the point 2 to GD0002. 1. Please note that in the above sample program, result of the calculation, distance, is added to the GR variable. Since the maximum value of the GR variable is 99,999.99, in case of calculation distance longer than 100 meters, it is necessary to use the GL variable. See the following example. x1 x22, y1 y22, z1 z22++. Program description. Sub GD0001 GD0002 difference between GD0001 and GD0002. GETELLR001 equals grand. X number 1. GD0001, take x element of GD0001. Mul LR001 LR001 raise the x element to the second power. GETELLR002 equals grand. Y number 1. GD0001, take the y element of GD0001. Mul LR002 LR002 raise the y element to the second power. Add LR001 LR002 add the square of the y element to the square of the XLA. Ment. GETELLR003 equals grand. Z number 1. GD0001, take the z element of GD0001. Mul LR003 LR003 raise the z element to the second power. Add LR001 LR003 add the square of the z element to the sum of the square of the x element and of the y element. SQRT LR001 LR001 calculate the square root of the sum to find the distance. Add GR001 LR001 *1, add the distance to GR0001. Ret end of the program. Application example tool 1, TOOL0001. MOVELP1. MOVELP2. CNVSETGD0001P1. CNVSETGD0002P2. Call PtoPlen. Add GR001 LR001 right pointing arrow CNVSETLL001 LR001. Add GL001 LL001 appendix. OM10090882E17325. 18.7 Sample program of TW. Flow of the program. 1. A handling robot clamps a work and transfers the work to above the work inserting hole. 2. Then the robot stops and rotates the TW axis. 3. While rotating the TW axis, the sensor detect the work and hole matching position and send the detect signal to the robot. 4. After receiving the detect signal, the robot stops the TW axis rotation and then insert the work into the hole. Structure of the program. Program name contents TWTEST main program. No mechanism. TWTEST1 transfer the work to the loading point. Rotate the TW axis. TWTEST2 move back to the shunting point. TWTEST3 insert the work. TWTEST main program. Program description. C. PARACALLTWTEST1 on transfer the work to above the inserting position. Parallel processing of the TW axis rotation. Wait underscore if I1 number 40, I1 number 0040, on T equals 0.00s wait for input signal from the sensor. Go on to the next step when the signal is received. C. PARACALLTWTEST1 off end the program to rotate the TW axis. Delay 0.50s, C. Call TWTEST3 execute the work insertion program. C. Call TWTEST2 execute the program to move to the shunting point. TWTEST1 TW rotation. Program description. Tool equals 1. TOOL01 MOVELP1 3.00 meters per minute. MOVEPP2 3.00 meters per minute work inserting point. Auto 1 number 40 shock face 1 number 0040 equals on notify the sensor to start sensing. MOVEPP3 25.00% rotate TW axis. MOVEPP4 25.00% rotate TW axis. Hold no signal error due to no signal from the sensor. TWTEST3 work insertion. Program description. Tool equals 1. TOOL01 GETPOSP hash P1 get the current position and orientation to P1. CNVSET LR number 1. LR001 equals P. Z hash P1 add LR number 1. LR001 minus 100.00 CNVSETP. Z hash P1 equals LR number 1. LR001. Add minus 100 to the Z direction value of P1. MOVELP1 1.00 meters per minute move to the new P1 position. Auto 1 number 39 shocked face 1 number 0039 equals on release the work. Delay 3.0s wait for time. CNVSET LR number 1 LR001 equals P. Z hash P1 add LR number 1 LR001 100.00 CNVSETP. Z hash P1 equals LR number 1 LR001 MOVELP1 1.00 meters per minute. TWTEST3 move to the shunting point program description. Tool equals 1. TOOL01 MOVELP1 3.00 meters per minute move to the shunting point.
चालेल.